right, so on to section 5.2, some indifference identities. So from the first bullet point, you can see that there's 6 of them. And so the question is, what do we need? Why would we need these, or what do we use them for? So we're going to look more from like a analytical view, a by hand view of what we might need that for. So for instance, give me some angles that you could find the sine, cosine, and tangent for, like get the actual ratio. And you think of an angle that you know, if you do the sine, cosine, or tangent, you'll know the actual ratio. All right, 90 degrees, not really gonna get you're gonna get 1 or 0, but let's do more of an opposite. Let's do more of an opposite over hypotenuse. Can you give me another angle? Right, 30 degrees. So 30 degrees, so if we did sine of 30 degrees, and we know, look at that triangle, draw a 30-degree angle. We know the sides. What's the opposite of 30? No. Yeah. It's just funny to me. Yeah, I mean, by now this is a trick. We gotta know that. Everybody. At least you tried, but do that. All right. So what do we get for sine of 30? 1/2. Okay, exact value. If we wanted, cosine of 30, what would we get? All right, so the main thing on exact value, what we're saying is this is exact value. And it's exact because square root of 3 itself is what? Like what type of number is it? It's irrational, right? So it doesn't, if you type it in on your calculator, if you type in square root of 3, it's like 1.71. It doesn't repeat, it just keeps going, changing around. So once you chop it, you're approximating. So we're looking more at a classical view on this topic today on how can we keep getting exact values, okay? So, all right, so we got 30. What's the other angle in there that you could get exact value? So we want exact value, sine, cosine, tangent, okay? Of course, if we can do these 3, then we can do, you already said 90, so I'm going to put 90 on there. That's right. What else? All right, what else? Good. All right. Very good. What else? Don't just think in quadrant 1. Very good, because if we do 120, we get a 60-degree angle, reference angle. Yep, 120. What else over there in the second quadrant? 150. What else? We're missing one. 135. Then you could do 180, and now on these, we're not going to use triangles. We're going to use what? Unit circle. That's right. You use unit circle on quadrangles. All right, so you got the idea. Let's just stop there. We've gone, and maybe what's the first most basic one I'm missing, what we could do? 0. Okay, very good. So let's just say we wanted sine, cosine, tangent of 0. Once we see 0, then we'll use unit circle. Okay, 0 degrees. What point is this right here on the unit circle at 0 degrees? No, 1, 0. And the 1 is the what of the angle? Which ratio? Cosine of 0 is 1, right? And sine of 0 is what? I can't tell you how many times we do this in calculus. Sine of 180. Cosine of 90. We do it all the time. Okay. So what do you notice at the pattern of the angles? Like, is there maybe a pattern or something that you see, or how about these? These are the ones I see. The ones I'm bouncing to. What's the gap for all of those? 30 degrees. And then the 45 to 135, that's 180, and that's the ones that ended with a 5 at the end, right? That's the bisector. Well, today, what we're gonna do is we're gonna add to this. Now, so what do we need sum and difference identities for? Here's what we can use them for. We're gonna be able to find like the sine, cosine, and tangent of maybe 15 degrees. We can't find that right now. Or say 105 degrees. And so on. You'll understand where I'm getting these from, like how's that possible? So right now at this point these are just two examples. So what do we need some identities for? Well, we have we can do it on the calculator. But what's the problem with doing this? What's the problem with doing sine of 15 degrees on the calculator? Go ahead, type it in. Make sure you're in degree mode, and you can tell me what the problem is. You'll want your calculator just like as a reference tool. We're gonna do more everything analytically.
It won't give you like an exact answer, like the radical.
Yeah, it's like, what's it giving you?
Decimals.
Yeah, just give me the answer.
0.25, like round to
Give
one.
me like 5 decimals.
0.25881, well, round to 2.
2.5882?
Yes.
All right, so, but we got the idea. So, again, something less than 1 when we're dealing with triangles. What triangle would this be? If it's a right triangle, 15 what? 75, 90. So, we're gonna add 75 to the list. While we're here, let's do sine of 75. Should be a bigger answer. What do you get?
0.965925.
0.96.
5925.
All right, that's good enough. Now look, I don't need a calculator for this. Cosine of 75, I don't need a calculator. I already know what it is. 0.25882. How did I do that?
75 is the same as cosine.
How's that?
Complementary. No.
Well, you got the right idea. Complement, or it's the co-function identities. The cosine of theta is you're right, complementary, you can say it like that, sine of 90 minus theta. So the cosine of 75 is the sine of 90 minus 75, which is 15. That's how I already got that, okay? All right, so store these. So I'm gonna just write these two down. Sine of 15 is 0.25882, and sine of 75 is 0.965925. All right, there we go. We'll come back to that. So all those are all rounded, okay? So those are not exact. All right, so instead of me deriving these identities, I'm gonna give you them now, all right? And I'm gonna show you how we interpret and use them, okay? So let's get started. So here's the first sum and difference identity. Sum and difference means you're gonna have more than one angle inside. You're gonna have either two angles added or two angles subtracted. So for the angles, we're gonna say alpha and beta. So if I have an angle plus an angle, sine of alpha plus beta, we wanna know what the answer is. Now, it is an identity, it's not what you think. It's not sine of one angle plus sine of the other. You can't distribute the sine. Okay, so that doesn't work. And I'll prove it to you in a second when we start plugging in numbers. So this is the identity. It says if you want to find the sine of this angle plus this angle, why would we want to do that? Well, I'm about to remember our 75 and our 15. I'm about to answer that. It would be sine of alpha cosine beta plus cosine of alpha sine beta. That is what you would have to do in order to evaluate sine of alpha plus beta. And if we want the sine of alpha minus beta, we would do sine alpha cosine beta minus cosine alpha sine beta. And you're going to be like, well, why is it like this? Well, I can do the derivation, but the derivation is very time consuming and it is thorough. I mean, it's hefty, right? So this just comes from other properties in trig. It actually comes from distance formula, believe it or not, in the unit circle. It's weird. But, you just like, it's one of these, just gotta take my word for it rather than me derive it, right? But here's how we can verify. So for instance, let's just take 75, because that's not a known, we don't know that, we don't have a 1575 triangle memorized with the sides. We don't know that. So if we wanted to find the sine of 75 degrees, well, this is what the identity is telling us. I don't know, I have no clue. I don't know opposite and hypotenuse for a 75-15 triangle. Can you take 75 and write it as either the addition or the subtraction of two angles that you know? If you can do that, because see, look what this says. In order to evaluate this, we're going to just do the sine of the first angle. We're going to just do the cosine of the second angle. This is why it's important to have those special triangles right here, to know all the angles and sides, because we're going to be using them so much. So like our 30, 60, 90, right, we want to have that memorized because we want to know straight away that the sine of 30 is a half. The cosine of 30 is square root of 3 over 2. And then our 45, 45, 90, what are the sides of a 45, 45, 90? 1 square root of 2. So both of those are 1 over square root of 2. So can we take 75 and write it as two angles added together that we know? What would you use? 45 and 30. So I would say this is the same as saying sine of 45 plus 30. So once I do that, now it becomes a plug and crank to the first line, the first identity there. So all you do, in place of alpha, you put your first angle. In place of beta, you put your second angle, okay? So shove that in real quick into this formula and just write this out. So you should, what you would have, sine of what, cosine of what, plus cosine of what, sine of what. Write them all out and then we'll go from there. All right, so if I plug it into the identity, I should have sine of 45 times cosine of 30 plus cosine of 45 times sine of 30. In place of alpha, I'll put 45. In place of beta, I'll put 30. And that's it. If you replace each of those with its ratio, that should be equivalent to sine of 75. So now what you're going to do is you're going to replace each one of these. Now notice it's multiplication here, then a plus, and it's multiplication here. Now, here's now where rationalizing will be helpful. So what I want you to do is you're going to put each of these ratios in. You're going to multiply here, you're going to multiply here, then you're going to add them. So one thing I would ask is rationalize. So for instance, the sine of 45, let's just do that real quick. If we look at the triangle there, what's the sine of 45? 1 over square root of 2, but if you rationalize, you multiply top and bottom by what? Square root of 2, so what does it become? Yeah, so I would sub that in for sine of 45. It's better to rationalize. Okay? All right, go ahead. Plug in each ratio and see if you can compress this, and this is will be the exact value for the sine of 75. There's not too much work to do. Once you plug it in, you really have a multiplication, then you should be able to add the two fractions. Okay, so sine, I'm going to point, you tell me what to write. Sine of 45. Cosine 30. Cosine 45. Sine 30. Oops. Okay, now when you multiply fractions, what's the rule? Multiply across, that's right. When you multiply square roots, the square root rule is you can make one house and do the multiplication. So square root of 2 times square root of 3 is square root of what? 6 over 4. Square root of 2 times 1, 2 times 2. Or we got to come denominator now, and we get square root of 6 plus square root of 2 over 4 is the sine of 75. Now, here's what I want you to do. Type this in on your calculator, square root of 6 plus square root of 2 all over 4, and you should get what? 0.965. You should get the exact same answer, except this is exact form. All right, does it check out? Yeah. All right, let me ask you, we're not going to do 15. We'll probably do, we may do cosine of 15 in a second. But if you wanted sine of 15, what would you have done? Actually, we can do it real quick. How would you do sine of 15 degrees? What two angles can you? 45 minus 30. We do 45 minus 30. So let me ask you this, look at the identity. So what's the difference in the plus identity for sine and the minus identity for sine? Yeah, you would subtract it. Everything would still go 45, 30, 45, 30. So it would be identical. Notice it goes sine, cosine, cosine, sine. Sine, cosine, cosine, sine. So the only difference is you'd have the exact same numbers except the minus. So if I wanted sine of 45 minus 30 real quick, if we wanted to do that, it should be sine 45 cosine 30 minus cosine 45 sine 30. It's the exact same pattern that we just had. And we have the exact, it's going to be the exact same ratio. So square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times a half. We get square root of 6 minus square root of 2 all over 4. Okay? Now, if you type that in, you should get your 0.25882. Okay? So it works the same way. It's just, my point is, it's just got a minus. So the only thing you're going to change is have a subtraction. Okay. So how many sum and difference identities are there? 6. So I owe you 4 more. Well, guess what? There's 2 for sine, there's 2 for cosine, there's 2 for. Now, I usually memorize them as 3. Like I can put those together in one identity. So what I'll do is I'll give you all 6, and then I'll show you how I group 2 together and see if you like it like that, then it's up to you, okay? So let's go ahead and list all 6. Here's that work there. Again, this is gonna be on the video, so if there's any questions about the math, you can go through, but again, when I multiply fractions, I multiply the top, I multiply the bottom. When I multiply square root of A times square root of B is square root of A times B. These are your basic rules of radicals. Okay, so now, and I guess it's like riding a bike for me because, you know, I don't use these identities every day, but somehow it's just in my memory. I was worried I would forget them, but I didn't. We would know if I had forgotten. How would we know? This answer wouldn't match up with that, right? It would be wrong. So yeah, exactly. All right. So cosine of alpha plus beta. Here it is. Cosine alpha, cosine beta, minus sine alpha, sine beta. So one thing you can always know is that it's always going to be the first angle then the second angle. Whether it's sine or cosine, it just depends on the identity. I know this is a plus and that's a minus there. That is how it goes. And then the cosine of alpha minus beta is cosine alpha, cosine beta. What do you think is going to happen? Yeah, plus sine alpha, sine beta. And had I derived, guys, this is the one I would have got first, had I done the long process. So I would have got this identity, and then I can tell you from here, I can get all the others. It's just not pretty. Okay, so why don't you try this one real quick? Let's see if you can do the cosine of 105 degrees. Now you pick, so what you need to do is figure out what angles do you want to use. If you're going to do the cosine of 105, what would be the 2 angles you might pick? Right, so we right now we can't do cosine of 105, obviously. Are there 2? Yep. There you go. So you're going to say cosine of 60 plus 45. And now you know you're going to use that identity there. And go ahead and write it out, and then you can always check your work on your calculator, okay? As we go, we'll do one example with each one. And these might be some of your homework problems, I don't know, so you might want to save your notes, save you a little work in your homework. let's look at this one. So it should be cosine 60, cosine 45, minus sine 60, sine 45. All right, so let's see, 60-degree angle, what's the cosine of 60? 1/2. Cosine of 45 minus sine 60, sine 45. Now you're gonna see when you do anything with 30, 60, and 45 with sine and cosine, you're always gonna get a variation of this square root of 2 and square root of 6. And there, now what does you get? You get square root of 2 minus square root of 6 over 4, and that's a negative answer because cosine is negative in the second quadrant. So it all should check out. Did anybody type in to get the decimal? What was the decimal for this?
-0.2582.
Should make sense. All right. Should have a 75-degree reference angle. Okay. All right. And now the last set is tangent. Tangent of alpha plus beta, tan alpha plus tan beta over 1 minus tangent alpha times tangent beta. It's a times thing here. 1 minus tan alpha times beta. Not pretty. Tangent of alpha minus beta, tan alpha minus tan beta over 1 plus tangent alpha times tangent beta. All right, now, here's the problem. You're going to do tangent of 105, and you're going to see that we need to make sure that our answer is rationalized. So you got to make sure at the end that you go through and do that. So you're going to get a fraction, so we're going to have to rationalize the denominator. I'm going to refresh your memory on that. So real quick, let's just say I had a fraction, 7 over 1 plus square root of 2. Let's just say this is what I had. So the radical is in the denominator. So if I want to rationalize, just multiplying by square root of 2 over 2, the square root of 2 over square root of 2 is not going to do it. Can somebody tell me why that's not enough? If I just multiply by square root of 2. Yeah, because of the plus 1. When I do square root of 2 times this square root of 2, yeah, it becomes 2. But then I do square root of 2 times 1, now I got a square root again. Then get rid of the radical. You know what you need to multiply by? What's that? Almost. It's 1 minus. You're going to multiply by the conjugate. If you multiply by the conjugate, that will get rid of the radical. So because it's like difference of 2 squares. It comes from that. So when you want to rationalize, and you have like I don't really have a way to do this. If you have a plus square root of b, you're going to multiply by a minus square root of b, a minus square root of b, something like that. Okay. And that will rationalize it. Whatever, if the square root's in the front, doesn't matter. Just multiply by the conjugate, okay? All right, so why don't you try tangent of 105, so we'll use this one. And we'll do the tangent of 60 plus 45, and let's work through that. So you've got, what's nice is tangent of 45 is nice. What's the tangent of 45? The loneliest number, 1. Okay, that's nice. Go ahead, see if you can get that, and then we'll check it on our calculator. And that is the big bulk of what we do in this lesson. That's not all of it, but that's the majority of what you're going to be doing. You get the idea. These are the worst because of the simplification. So I'll help you with that. And then we'll do one more type of problem, and that's about it. That's it. cominciano le altre. So I'm gonna erase, and I'm gonna rewrite these identities in a second, so we can work this problem here, so. Alright. You should get a 1 minus square root of 3 on bottom. If you don't, you've done something wrong. Then you gotta multiply by the conjugate of that, okay? The computer may allow it, you'll know. You try stopping early, it may say you need to keep simplifying, okay? So let's go ahead and plug in and see what we got. So if I use the identity, it should be tangent of the first angle plus tangent of the second angle over 1 minus tangent of the first times tangent of the second. All right. And now this is where you want to have these memorized, right? So tangent of 60 is what? Tangent of 45, 1 minus tangent of 60, square root of 3, tangent of 45, 1. So on the bottom, we just get 1 minus square root of 3, okay? Now, you might try this and see if the computer will take it. I don't think so. Because you found the answer. It's not pretty, but you got it. They probably won't probably won't take this. So I gotta just follow the rule there. So I'm gonna multiply top and bottom by 1 plus square root of 3, and I gotta do 2 FOIL methods. All right, so let's see what happens. First, I get square root of 3. Outer square root of 3 times square root of 3, we get what? 3. Inner, 1 times 1, we get 1. And last, 1 times square root of 3, we get square root of 3. We'll come back to that in a second and clean it up. Now, when they're conjugates, save you some time. What part of FOIL do you not have to do when you have conjugates? Outer and inner. Yeah, because they'll cancel. See, you only need to do first, you get 1. I'll do outer and inner just to show you, but if you do outer, you get square root of 3. You do inner, you get negative square root of 3. I could have saved myself time. That's the whole reason we're doing this, because we don't get a radical on the bottom. Those cancel. Last, negative square root of 3 times square root of 3 is negative 3. And so now, let's just combine everything. What does the top become? Very good. Yeah, yes. 2 square root of 3 plus 4. Yep. All right, what does the bottom become? Negative 2. Now, here's the thing. Since there's a 2, at least a 2 in each term, you can cancel a 2. See? You can cancel this 2, this 4 reduces to 2, and that's gone. Then I would move the negative up and negate everything. Okay? So that cancels, but it has to be in every term. So I get negative square root of 3 minus 2. And now that should be the answer. If you type that in, you should get about negative 3.7. If you try tangent of 105 on your calculator, you should get about negative 3.7. See or no? Okay. So yeah, these are the tangent I hate. I'm not a big fan of. All right, now let me show you how I compress the identities into just 3. Are there any questions on the work there, what we did? So just to make sure, I canceled a 2. Now I moved that negative up and negate it also at the same time. All right, so here's how I'll put the identities. See if you like this. So I'll do, see if it will show up, yeah. So here's how, let me erase this start here. So here's the identities, 6, sum and difference, not smooth. 6 sum and difference, okay. I do this sine alpha plus or minus beta. I go ahead and just put both, because it does this. Sine alpha cosine beta. Now what do you get? When it's a plus, what do you get here? Plus. When it's minus, what do you get? So I'll put plus or minus cosine alpha sine beta. So I've written those two as 1, because the pattern was the same. It wasn't sine alpha cosine beta, cosine alpha sine beta, just whether it was a plus or minus. Then I do cosine of alpha plus or minus beta is cosine alpha cosine beta minus plus sine alpha sine beta. Do you understand why I went minus plus? When this is plus, that's a minus. That's minus, that's a plus. Tangent of alpha plus or minus beta, tan alpha plus or minus tan beta over 1 minus plus tan alpha times tan beta. And there you go. There's a 6 written as 3. Just compresses it a little bit. All right. One last problem to share. One last type. I think now you've got that identity down. And here's the last type of problem. I don't know what example this is. Just call it example. Given sine of alpha is 12/13 in quadrant 2. That's a quadrant 2 angle. And sine beta is 3/5 in quadrant 1. Okay? So alpha is in quadrant 2, beta is in quadrant 1. Find the following. Cosine alpha, cosine beta, cosine of alpha plus beta, sine of, sine of alpha plus beta. Now, real quick, before we start working this. So, how are you going to figure out what this cosine of alpha is? How would you do that? This is chapter 4 material. We're back to what? Using what? Triangles. If I ask you how you're going to find cosine alpha, the answer is I have to do this. Draw a triangle. This way you have to draw a triangle. What's that?
This is gonna sound dumb on a graph.
Yep, where?
In quadrant 2 and
Yeah,
quadrant 1.
no. For alpha in quadrant 2. And the sign plus or minus is important of your answer. This is a review. This is a 4.4 problem. We did this in section 4.4. It's been a while. So find the cosine of alpha. The only way you're going to get that, draw the triangle on a graph. Which is the exactly right answer. I'm giving you a hint. You got to notice the plus or minus of your answer. You got to label your triangle correctly. That triangle should be known. If you know it's 12/13, then you should know the third side using Pythagorean. You shouldn't need Pythagorean theorem. Is what I'm saying. And then sine beta. What quadrant is beta in? 1. So since beta is in quadrant 1, what do you know about all the sides in quadrant 1? There you go. Now you can find cosine alpha, cosine beta. If you don't get these, then forget about doing this. So this is old, this is new. A and B is old, part C and D is new. Okay? So let's get A and B first, and then we'll check your work. This is the last thing that we're doing today. Did you get this? I'm going to turn you loose. Okay, so let's check and make sure you got the right answer for cosine alpha. So I'm going to draw angle alpha. It's in quadrant 2. I don't know exactly where, but I'm just going to draw it. I'm going to make my triangle. All right? Right now I know what two sides of the triangle. Yeah, opposite and hypotenuse. What's the Pythagorean triple that goes with 12 and 13? What's the missing side? 5. But since that is also the x coordinate here, this 5 needs to be what? Negative. Now you can get cosine of the angle. So what's cosine of alpha? Yeah, negative 5 over 13. If you don't put that, it's going to be wrong. Right? Cosine beta. So I'm just going to use the same graph. Beta is in quadrant 1. Draw my perpendicular. I got opposite is 3, hypotenuse is 5. What's the adjacent side? 4. So what's the cosine of beta? 4 over 5. Is that? Okay? All right, now, here's where you don't overthink it. So I have sine alpha, sine beta, cosine alpha, cosine beta. If I want cosine of alpha plus beta, what's the first thing I should probably do? If you don't know these actual angles, you don't need them. Yeah, so what's the first thing I should probably write right here? The identity. Just write it out. So what's the cosine of alpha plus beta? Who can tell me? Cosine of alpha.
Cosine of alpha times cosine of beta minus sine of A of alpha times sine of beta.
Now it becomes what?
Plug.
Plug and crank. That's exactly right. So the answer, when you get an angle plus an angle inside of sine or cosine, you're gonna need the identity. Then you just plug everything in. And you'll have a couple of fractions, you get a common denominator, you should have a common denominator. Then it's over, it's done. And then do the same thing on part D, expand, write your identity, then sub in. So you're gonna sub in for each of these, don't forget there's a minus in between them. That's it. Fairly straightforward. It's a review of the old, where you're finding the old answers and then you use them in your new identities. All right. Can somebody tell me what to plug in? What goes here? Yep. Times what goes from beta. All right. Minus what goes to sine alpha. Times sine beta, what goes there? All right. Now just don't mess up on your minus signs and don't mess up on your multiplication. So when I multiply the first two fractions, what do I get? Negative 20 over 65 minus this becomes what? 36 over 65. That's right, you should get negative. Yeah. All right. That's the answer. Same idea here. Sine of alpha plus beta. We're going to do sine alpha cosine beta plus cosine alpha sine beta. Plug everything in. You report it from there. So the nice thing is we get a common denominator each time. All right, tell me what's right, sine alpha. 12/13 cosine beta, 4/5 cosine alpha, you get 5/13 cosine beta, 3/5. Okay. You should get 48 over 65 minus 15 over 65, so you should get what? That's it. And that's what you're going to be doing. So basically, what do you need to have near you on probably the majority of the problems? Yeah, your identities. That's it. Okay.